For decades, the baseline for a Python development environment was focused on three things: localized text editing, code refactoring, and basic debugging. But for modern teams building distributed services and data products, that historical baseline is no longer enough to maintain momentum. The primary bottleneck in a modern developer's day isn't the logic itself. It is the time lost to complex environment management, endless context hunting, and generating repetitive boilerplate. We see this in a consistent 30-70 split. Only a fraction of the day goes toward implementation. The rest is consumed by the glue work required to keep a project moving. Because glue work is the primary tax on productivity, any tool claiming to improve developer speed must mechanically eliminate these specific non-coding bottlenecks. This requirement is driving PyCharm's evolution from a standalone code editor into a comprehensive development control center. This shift integrates highly specialized, historically distinct toolchains directly into a single, cohesive environment. By housing AI agents, compiled language interoperability, and advanced package orchestration under one roof, the IDE can address the macroscopic needs of the entire project. This manifests as a repeatable 5-stage cycle: setup, scaffold, explore, debug, and optimize. We call this engineering the loop. By integrating these discrete stages into a singular, continuous loop, the IDE absorbs the complexity of modern software architecture, allowing the engineer to focus exclusively on logic and design. The loop begins with setup. Historically, this is where projects stall due to the friction of environment orchestration. Python environments often carry hidden costs: slow onboarding times, conflicting lock files, and subtle dependency drift that causes code to fail when moving between machines. To solve these discrepancies, PyCharm has integrated UV workflows directly into its environment management system. UV standardizes the environment by prioritizing fast installations and requiring explicitly clear dependency intent. When you can clone a repo and sync a complex environment in seconds, every downstream action, from code reviews to incident response, happens faster. Establishing a rapidly reproducible ground truth is a mandatory first step. It ensures all subsequent work occurs in a predictable, stable environment. Once the environment is stable, we move to the scaffold phase to build the architectural skeleton of a new feature. Here, it is important to distinguish between simple autocomplete and goal-oriented AI agents. Autocomplete predicts your next line. An agent executes a multi-step plan. Imagine instructing an AI agent to add a new endpoint to a fast API service. The agent acts across the codebase simultaneously. It drafts the configuration plumbing, adds the pydantic schema, and generates the necessary test scaffolding. This output is a first-pass proposal. It is a draft that requires human validation before it is ever committed. This changes the developer's role. You treat the AI as a fast junior teammate who handles the repetitive setup while you act as the lead. By offloading the mechanical construction of the scaffold, you preserve your energy for evaluating system design, trade-offs, and edge case correctness. AI agents function as implementation accelerators. They compress the time required to move from a blank page to a testable prototype, removing the heaviest part of the glue work tax. The third stage of the loop addresses the explore phase, workflows that require rapid investigation before strict engineering can begin. This highlights the historical tension of Jupyter notebooks. They are essential for AI and data science exploration, but notoriously difficult to translate into production-ready software. Integrated AI support bridges this gap by analyzing exploratory code blocks and summarizing their underlying intent for future readers. If an exploratory cell proves successful, the tool can automatically refactor that messy code into a clean, reusable Python function. It also drafts the guardrails often skipped during experimentation: input checks, shape validations, and logging protocols. These upgrades transform exploratory work from a disjointed side quest into a strictly governed part of the software engineering pipeline. In the final stages of the loop, code must be verified against reality and optimized for performance. PyCharm now uses DebugPy as its default debugger. This ensures strict consistency when stepping through complex async code or remote environments. While AI can hypothesize about why a bug exists, the deterministic debugger remains the ultimate source of truth for verification. To prevent navigation lag as a codebase grows, engines like PyRefly provide rapid code intelligence and indexing, keeping analysis fast even in massive monorepos. Eventually, you may hit a CPU-bound bottleneck, like heavy text parsing or tight loops, where native Python is no longer efficient. The modern solution is selective optimization. The slow Python process is swapped for a high-performance Rust extension. You implement the performance-critical piece in Rust while keeping the rest of the orchestration logic in idiomatic Python. Integrated multi-language support allows you to navigate and maintain this boundary without switching tools. By providing native boundaries for both rigorous debugging and compiled Rust extensions, the IDE ensures performance scaling doesn't require a total system rewrite. Despite these technical accelerants, a healthy workflow requires a clear boundary between automation and engineering. This is the human review gate. AI-generated code is not guaranteed to be correct. It can introduce subtle insecurities or concurrency flaws if it is not thoroughly vetted. AI agents also lack hidden context. They miss specific deployment constraints, strict compliance requirements, or backwards compatibility needs. Architectural design remains your responsibility. Choosing interfaces, defining error handling, and managing performance budgets are human decisions. The goal is extreme speed paired with extreme vigilance. AI accelerates the loop, but the human engineer retains absolute ownership of the system. A modern Python workflow must balance rapid, messy exploration with the rigorous engineering required for production. PyCharm reflects this reality by housing notebooks, AI agents, Rust extensions, and UV package management in a single environment. This evolution represents a deliberate architectural focus on the entire project lifecycle. By mechanically eradicating friction at every phase of development, the IDE enables engineering teams to ship complex software faster. Embracing an integrated environment allows you to radically increase your iteration speed without sacrificing your engineering discipline.